Now we have our current student in AIoT program. So may I invite Mr.Chakapat Chokchaisiri from SIIT, Thammasat University, to present about enhancing iris verification through multiple distance measurements, fusions, and enrollment. Please.
Okay. Hello, everyone. My name is Chakapat Chokchaisiri. I am currently a master degree student from under the TAIST scholarship and AIoT program. So since I am currently the master degree student, I don't have much story like the previous person. So today I'm gonna present about my research work in topic enhancing iris verification to the multiple distance measurement fusion and enrollment screening mechanism. And this research has financially supported by the Thammasat University, SIIT, NASDA, and Institute of Science Tokyo. So this presentation will be going on following this outline: introduction, research objective, proposed method, experiment and result, and ending with Q&A. So biometric authentication, just like the fingerprint, face, voice, and iris recognition, is widely used to identify the person by using the pattern that expect to remain the same over time. So nowadays we have a lot of biometric authentication application. Just like today you use your fingerprint to unlock the mobile device, or using your face scan to confirm the banking payment. So among that, iris verification system is trusted for its outstanding performance, unique and unchangeable pattern, unlike the other biometric that can be changed due to aging. And as you can see, the blue area that you can see, we call it iris, and the completely black circle area inside, we call it pupil. Biometric market share is growing rapidly, with the iris recognition market share was projected to reach $8.4 billion by 2027. So in the past, Thailand has faced the problem that we have so many illegal laborers from the other countries that living in Thailand. Thai Red Cross say that even if they're living in Thailand illegally, they also have the human right. They should have received the vaccine during the COVID-19. But since the vaccine you have to receive at least 2 doses, they have to collect some information from the laborer. So to identify them individually was a challenge. So Thai Red Cross came up with the solution that they use the iris verification to collect the information. And this case also work with the farmer, that they cannot use their fingerprints because they always use their hand to the farming work, and they cannot use their facial scan due to their face facing the sunlight every day. So a lot of researchers that trying to improve this framework. Most of them are based on the iris verification framework, which consists of 4 main stages: the segmentation, normalization, encoding, and matching, which the detail we will explain later. So my research objective is trying to improve the overall accuracy by decrease the false prediction. So from our experiment, the segmentation state is cause a lot of the false negative case, and the matching state, they cause a lot of false positive case. So in document framework, in segmentation, document use the half circle to find the pupil boundary and the active control to find the outer boundary or the iris boundary. So after he got these 2 boundary, the area between these 2 will become the iris area. In the normalization stage, document convert the iris shape, which is looking like the donut shape, into the rectangular shape to be easier to do the image processing. And in encoding stage, document use the log cable filter to convert the normalized image into the complex number, and the complex number can be converted into the binary based on the face or the quadrant of that complex number. In matching stage, document use the Hamming distance to measure the difference or the similarity between 2 templates. So this will show you a little bit how Hamming distance work. We count the different bits and divided by the range of the data So in this case, as you can see the highlight, the Hamming distance we get of 0.3. And we got some fine tuning threshold. If the Hamming distance we got is lower than the threshold, we call it matching, or the same, or the two iris template are from the same person. Otherwise, it is mismatching, or the two iris template are from the different person. So let's say that the image taken from the camera may not be on the right angle, it can be rotating. So Duckman uses template shifting mechanism. He moved the mode left hand side. So in this example, he moved the mode left hand side part into the mode right hand side. So what happened is it's just like you rotating the iris image. So he doing this 8 times to the right and 8 times to the left, including with no shifting one. He got 17 Hamming distance template, Hamming distance value in total, and the minimum value will be considered to determine that it is from different or the same person. So I got some previous work that already proposed. So I trying to improve the segmentation stage by using the SAM, or the segment anything model, which is the public AI meta team powerful image segmentation model. So I try to improve the segmentation state by using this model. So I propose some method to select the initial point for this model, which if you have any question, we can discuss about this one later. And in matching state, we found that in the all 17 shifting template, there is information on that all 17. So we change the neural network to feed all 17 value and predict to improve the matching state even more. So this is how my previous framework worked. So let's say that the Hamming distance value will be in range between 0 and 1. We got some threshold just like we talked. So in the left hand side part, we found that they cause a lot of false positive case, which we improved by using the neural network to feed all 17 Hamming distance value. With this solution, we can fix a lot of false positive case. So in this research work, I'm trying to improve even more in the segmentation and matching stage. So instead of just using Hamming distance value, I add 2 more distance measurements. The first one is Jack-Cut. Jack-Cut is 1 minus by the intersection of 2 templates over the union part of that 2. And I use the Pearson correlation coefficients, which I can see the linear relationship furthermore. So I feed all 3 distance measurements and 17 per each into the neural network to improve the matching stage. This is how my framework works. So I can say that if the Hamming distance is very low, we can almost guarantee that it is matching. And if it is very high, we can guarantee that it is mismatching. And the area between the first and the third threshold, we call it uncertainty. We're not sure that it is matching or mismatching. So I train 2 different neural networks to fix the false positive case and false negative case for each side. So in this research, I use the Cassia Iris version 2, which contains the 60% and 20 images per each, taken by the near-infrared range camera. So with this solution, I can increase the balance accuracy for about 20% and recall for about 20% as well. So in the segmentation state, I'm trying to improve this stage by adding some image quality checker between before it doing some processing. So with this solution, I can ask the user to take the image again if that image doesn't meet the condition or they have the bad condition image. So this is how my image quality checker worked. So I measure the distance between the inner boundary and the outer boundary, and we can calculate the variance from this distance between 2 boundaries. And as you can see let's say that the A image is the good image condition. You can see that the distance between inner boundary and the outer boundary is quite stable compared to the E image, which the distance is really different. So the variance from the E image is very high. And the graph below, we can see that the x-axis is variance and the y-axis is the number of image. From this one, we can see that most of our data set will be in good condition. So we reject some part that the variance is very high. With this solution, we can improve the every way possible of our indicator. So this is a conclusion of my research. We propose two more mechanisms. Let's see the left-hand side first. We use the multiple distance measurement that we add two more Chakapat and Pearson distance. So with this solution, I can increase balance accuracy for about 10% and recall for about 20%. But after we integrated with enrollment screening mechanism, we can increase every way of possible significantly on precision for about 26%, the F1 score for about 10%, the F0.5 for about 14%. And that's it for my presentation. Please feel free if you have any question.
Thank you. That is very informative.
Yeah.
So do you have any questions for Mr. Chakapat ka? Okay, I have one. So why do you decide to study this topic, this research topic? What is inspire you, or what is your passion?
In the first time when I studied the master degree, I don't have in my mind that what I want to do exactly. So they give me the list of the topic that the researcher interested in, and I just pick one from them that I see interesting. Yes.
Okay. All right. That's pretty easy. So good luck on your study. I wish you luck. So thank you again for coming here today. Thank you very much. Give a round of applause to Mr. Chakapat.